We'll go ahead and get started. My name is Sean Maurer with the Smart Energy Design Assistance Center. Joining me today is Todd Abercrombie as a guest speaker. We're going to be going over energy code testing and verification today. Just a couple of quick housekeeping notes. If you have questions during the presentation, please enter them into the question and answer window pane. You can find that by hovering over the top center or bottom center of your screen. You'll see a Q&A button there. If you do enter questions into the chat, we might miss them. So please do use that question and answer pane to make sure we answer your questions as we go along. What we're going to be covering today, we're going to be learning which sections of the Illinois Energy Code require testing and verification on both the commercial and residential side. We're going to understand what those requirements for testing and verification compliance are. We're going to learn how to test and verify the required portions of the Energy Code for new construction and then also for existing buildings. CDAC is a preferred education provider for the International Code Council, so we do offer credits for that as well as the AIA. After the presentation concludes, you'll get an email from us with links to request those continuing education credits, and we will address that for you. So who we are, the Smart Energy Design Assistance Center is an applied research program at the University of Illinois. Our mission is to reduce the energy footprint of Illinois and beyond. The Energy Codes training program is one of our largest programs working towards that goal. The program is sponsored by the Illinois State Energy Office at the Illinois EPA, and we thank them for their support of this program and bringing this training material to you. At our website, smartenergy.illinois.edu/energy-code, we do have a number of resources as well as contact information to reach us with your questions. We do prefer that you use our email address, energycode@illinois.edu, to reach us. That gives us time to review in our office and get you the best answer. However, if you do need a quick analysis for an energy code question, we do have a 1-800 number listed there that you can reach out to us and we'll answer your question as best we are able. Our website also contains multiple links to our past workshops and webinars, self-paced online training courses, and a link to those technical support contact information. We also have direct links to the Energy Conservation Code at the IECC website, as well as the Illinois amendments and the Chicago Energy Code amendments. We also have links to our frequently asked questions and other useful websites. So this is part of a series of webinars and workshops. Through the fall, we've covered these topics and we're going to be covering them again in the spring here, comparing the ASHRAE 90.1 requirements to the IECC for envelope, mechanical, lighting and electrical, and performance-based compliance. So if you were unable to attend a previous session, we're bringing those back in the spring so that you can attend that. Joining me today is our guest speaker, Todd Abercrombie. He's the president of Midwest Building Performance based in Peoria, Illinois. They perform energy audits on homes and businesses to improve comfort, value, and efficiency. So in today's presentation, I'm going to go over kind of the specific code language and requirements, and then I'll hand it over to Todd. He'll bring his in-depth knowledge of field experience and actually conducting these tests to kind of fill you in on how they're performed and answer those types of questions on the details of actually performing the verification and testing for energy code compliance. So to get into our presentation a bit here, what portions of the code require testing and verification? So we're working out of the 2018 International Energy Conservation Code. Be aware that we are going to be transitioning to the 2021, so where there are significant changes, we'll touch on those briefly in the presentation here, but most of this information is based around the 2018 IECC's requirements. Uh, Probably the biggest one for buildings is envelope air tightness. On the commercial side, you do have the option to do air barrier testing with a pressure test. Um, for the 2018 IECC, that has to be the ASTM E779 pressure testing. Um, we do note here that as we transition to the 2021, there are three pressure tests available to residential. Those will all become available for commercial as well. So that'll be the ASTM E779, the ASTM E1827, or the ResNet 380 pressure testing standards. What we want to touch on here are what are the main differences between those, so you can kind of understand which ones impact your projects. As I noted before, in the 2018 IECC, ASTM E779 is available for commercial and residential pressure testing. It's the standard test method for determining air leakage by fan pressurization. So this is set up for single zone buildings without strong winds or large temperature differentials. Pretty much all of these tests have that requirement for the building pressurization. If you got a building with multiple zones, you have to make sure doors are open between them so that you're pressurizing the space equally. For commercial buildings, you can break it up into sections and do sample testing. You're testing air leakage based on envelope area, whereas on the residential side, you're doing it based on square footage of the building. On the residential side, the ResNet IEC and ICC 380 is the most different from these because it also includes testing for duct pressurization, ventilation systems, and so it has some of those additional residential tests that are required, where the other two standards from ASTM, those focus specifically on pressurization of the building envelope for leakage detection. So largely these standards are interchangeable on the blower door side. The ResNet 380 standard is what we use for the blower duct blaster testing for duct leakage testing. So for duct leakage testing, again, on the commercial side, the only time duct leakage testing is required is if the duct design static pressure is 3 inches or greater, and you must test per the SMACNA HVAC test manual. On residential, all ductwork that exits the building envelope, say it's in an attic space or a crawl space that isn't conditioned, then that ductwork does need to be tested for leakage. For the 2018 IECC, if all that ductwork is within the building envelope and within that thermal envelope, then the testing requirement is not required, but sealing is required. Because commercial buildings are much more complex, they've got control systems in place. The next few sections are commercial only, where you've got to actually test and verify the functional performance of the control systems for those buildings. Since we've got things like economizers, thermostat setbacks, temperature controls, demand control ventilation, all those things need to be verified that they're working properly through a commissioning process. And so that is documented in the C408 section of the code, and C403 requires that testing to be done. So as you're working through the code, all sections of C403 and C404 for HVAC controls and surface water controls, where those control requirements are in place, you'll have to do some kind of testing and verification to make sure that they are working properly. That process is laid out in the C408 section. Similarly, for commercial lighting, again, you've got controls on the lighting in place for occupant sensing, timers, daylighting controls. All of that needs to be verified working properly and in the correct sequence so that you don't have lights on when they're not needed. And again, The lighting sections list those controls. The testing requirements are listed in C408 of the Energy Code. And so real quick, we just have a quick poll question to kick off the first section here. I will launch that now. The first question is, which pressure testing standard is allowed for commercial blower door testing per the 2018 IECC? The ASTM E779, the ResNet 380, or the ASTM E1827? And then, which is true of duct leakage testing? Duct leakage testing is optional for both residential and commercial. Commercial only requires high pressure ducts to be tested, or commercial and residential require testing of the entire duct system. We did have a question I see popped up in the chat. For existing commercial buildings, are there companies in Illinois that do pressure testing as a service? As I believe that came in while we were doing the building pressure testing. Yes, I think Todd can touch on that a bit more, but pretty much anyone that is certified through the Building Performance Institute or ResNet that can do residential testing could do commercial pressure testing in smaller commercial buildings. They likely may not be equipped to do a large commercial building. And there are agencies that are able to do larger buildings, especially since future codes are going to be requiring pressure testing for most structures. Todd, do you know of any larger commercial pressure testing agencies? I don't know any off the top of my head.
Yeah, not off the top of my head. I do know there are large building certifications that are coming to market. I know the Air Barrier Association of America has got one. I think they're actually teaching it next month here in the U.S. But you're right. When you get the initial blower door testing, your mainly focuses on a residential building in terms of like BPI and ResNet and whatnot. So anybody who's got those certifications are capable. The question is, do they have more than one blower door? Do they have the apparatus and the hoses and all that to do the large testing?
So to look at our poll results here, question number 1, for commercial blower door testing in the 2018 IECC, it must follow the ASTM E779 standard. Looks like most people got that. In the 2021, all 3 of those standards will become available for commercial buildings. But for the 2018, it is the E779. And then what is true of duct leakage, the second response there, only high pressure ducts for commercial require testing. For residential, testing of the entire system is required if it exits the thermal envelope. It is mandatory for residential. You have to test it. The results of the testing can be traded off for the performance path. We'll touch on that later. But the testing does have to be done. It's required for residential. So that's incorrect for the last option, or for the first option. And for the last one, commercial requires only testing of that high pressure duct section. So low pressure ducts that are in that lower pressure class of 1 or 2 inches, those do not require testing. So a little bit of a tricky question there, but it looks like most people got it correct, that only that high pressure section of commercial ducts is the correct answer there. So now we'll get into we touched on what sections of the code require testing and verification. So now we'll dig into the actual testing and verification requirements a bit here. For envelope air leakage testing, for commercial buildings, it's a slightly higher pressure than residential. You're testing at 75 pascals, whereas residential, you're testing at 50 pascals. For commercial buildings, leakage is based on exposed envelope area, where residential, it's based on volume. So you're doing an air changes per hour at 50 pascals. There is an Illinois amendment for multifamily buildings that does allow square footage of building envelope there, but that's a special case, and it is an Illinois amendment. The commercial testing allows you to do samples of areas of the building. There are specific areas of the building that must be tested. So areas that are directly under the roof deck have to be tested. Um, Buildings with entry or sections of the building with entryways need to be tested, and then covering the envelope in a sample of the overall square footage. So you don't need to test every exterior portion of the building, but you do need to test under the roof deck where you've got openings for entryways, and then you can sample the rest of the envelope. And you must meet that 0.4 CFM per square foot target at 75 pascals. Um, Whereas residential, you're testing the whole building. You're always doing that whole building test. You're not doing samples, and you're doing a compliance at 3 air changes per hour per the energy code. Illinois amendment does allow that to be 4 air changes per hour, although that will be going away with the 2021. And another change in the 2021 was noted in the chat here. Um, there is a CFM per square foot coming for small buildings for residential. Um, so that'll change that whole building from a volume to that CFM per square foot of envelope area. But why are we doing this test? We want to ensure that that envelope is sealed um, so that you're limiting air changes in the building that are uncontrolled. We're wanting to make sure that that envelope isn't going to have issues with humidity entering, that you can have condensation damage, things like that. So that's why this test is important to do. And Todd will touch on later the actual methods of sealing up the building for the test, what should be sealed, what shouldn't, as far as sealing up air vents and things like that in the building. So those are the requirements for that leakage testing as far as what the code requires for compliance. Again, that commercial option is an optional test for the building. If you select that method for compliance, then you must meet those. Otherwise, you do have in the 2018 IECC, the option to just through verification of the air barrier materials and proper installation practices be in compliance. So who does the testing? For both commercial and residential, it's usually a third-party contractor, but it can be the builder or designer for the project. We usually see that for residential. A builder may opt to do their own testing in some cases, or it may be the insulating contractor. The main requirement is that whoever's doing that testing must be approved by the authority having jurisdiction. So your code official has to approve whoever's doing that test. And usually if we see the builder doing the test on the residential side, the code official will usually request to be present at the test to make sure that it's following the proper procedures. As far as envelope insulation, there isn't a section of the code requiring testing of this, but there is a verification that needs to happen. So your code official will come out, look at the insulation, make sure it's properly installed. For fibrous insulation, you're making sure that it's in full contact with the surface to be insulated. You don't have gaps, voids, or compressions in that insulation. If you're doing spray insulation, you're making sure it's proper depth for the product to qualify as an air barrier if it's part of the air barrier of the building, or that it's just proper depth to meet the R value that's specified in the plans. For blown-in insulation, if you're looking at that for your structures, it's a bit of a combination of the two. Again, just as with fibrous insulation, it needs to be in full contact. It's not going to settle away and leave gaps at the tops of your framing cavities or something like that. But you're also checking for proper depth of that insulation, make sure there's no, some of the spray-in insulations have a wet spray-in applications. They stick to itself and adhere to the frame. Some of them are blown behind netting. The ones that are blown behind netting usually don't have a problem with ensuring proper depth as you're just filling that cavity. But the ones that are kind of a wet apply spray insulation, those can have some variations in depth that need to be verified. And again, it's the code official that's coming out to do that inspection uh, as a final inspection for compliance. But we highly recommend that the builder, the architect, designer for commercial buildings, the builder for residential is inspecting that periodically along the way, just to make sure that you don't have an issue that gets covered up by another part of the building structure. It maybe hides an issue with air barrier compliance or with proper installation of the insulation. So periodic checks are recommended. They're not required. The only required inspection and for verification is when the code official comes through and does their checks. For duct sealing on the commercial side, again, if you've got that high pressure duct system, um, it needs to be tested per that. It's the Society of Mechanical Air Conditioning Contract. No, I may have that wrong.
Close.
It's hard to remember because
SMECNA.
it's such a long acronym. But duct leak, they have a duct leakage test manual that specifies the testing procedures. In the energy code, it specifies that duct leakage needs to be a leakage class of 4 or less. And so if you're testing at 3 inches over 100 square foot of ductwork that you're testing, that is a leakage rate of at 3 inches of 12 CFM per 100 cubic feet. So the way that works out is if your test pressure is 1, the leakage class equals the test pressure. At a test pressure of 3 inches, if you're testing it at a higher pressure, there's an exponent on that that's applied to it. So it may not be exactly 3 times higher. It's slightly less than that. But that's how that test is performed. You follow that manual, you find the leakage class for the ductwork. It must be 4 or less in the test. On the residential side, you must pressure test the whole system. For ductwork that has the blower unit installed, the furnace already in place, the leakage is 4 CFM per 100 square foot of floor area, not duct surface area like with commercial. If you don't have the furnace installed, you have to test the supply and the return separately and add those values together. And it must be less than 3 CFM per 100 square foot of floor area. So an important distinction between the commercial and residential. Commercial is specifically testing per duct surface area as far as the leakage class. For residential, it's per square footage of floor area. So do not confuse those requirements. Who does the testing? On the commercial side, it's usually going to be your HVAC contractor that completes that pressure testing. One thing that is detailed in that pressure test manual is, as the designer, you need to specify the pressure class for your ductwork. Otherwise, they assume a certain leakage class level, which may not be in compliance with the energy code. So specify the leakage class for the ductwork that needs to be tested so that the contractor knows that the testing needs to be done and it needs to meet that specific requirement. As far as duct sealing, both residential and commercial are required to have duct sealing regardless of the pressure level of the ductwork. And so that should be inspected periodically through the installation process of the ductwork to make sure that's being done properly. Usually it's all your transverse seams need to be sealed. Lateral seams need to be sealed. Joints between collars on ducts should be sealed up properly. And then the code official is going to do kind of a spot check when they come through for their site visit and make sure that all those seams are properly sealed up. They may need to pull insulation away in certain areas to check that and then put the insulation back. Or it may be done in phased visits. It depends on your code official when they do that duct inspection. On the residential side, the raters can do that inspection and report it, or the code official can do that as part of their walkthrough inspection of the building as far as sealing. As far as the pressure testing results, usually that's going to be the rater who's come out to the building. They'll do that test, supply a report. The report needs to have the duct leakage results with a signature on the form. We have seen a couple of those forms come in without a signature on them, in which case it would not be in compliance with the verification requirements for the energy code. So you do need to have a duct leakage report with the testing entity's signature on it to be qualified as properly verified for that leakage test.
Sean, can I jump in for a second?
Mhm.
So I highly recommend, so one of the mistakes I see in the field is they learn they need to do the duct pressure test too late in the game, such as drywall's already up. And so they're nearly into construction, and then we come in, and if the duct pressure test doesn't pass right away, it needs to be sealed more. And getting that done after drywall is much, much more difficult than doing it pre-drywall. If you're doing the test, basically a rough in, where you can see all the ducts and get to them all, it is much easier to make sure that system is going to pass that test. So whenever possible, get that test done before a rough in. I've done a number of tests before we even had electrical installed that I had to bring my own power to power the fan. But by far, that's a better scenario to test in. So if there's any issues, you can fix them.
And as noted before, there is an exception if all your ductwork is within the thermal envelope. The duct leakage testing is not required, but the duct sealing is, and that does still need to be verified. So again, especially if you're hiding ductwork in a soffit or somewhere where it's behind drywall and not easily viewed, may want to coordinate with your code official to come out and do that duct sealing inspection. Even if all that ductwork is within the conditioned envelope, they do need to verify that the sealing has been done, even though there isn't a pressure test required. As far as commercial HVAC and lighting commissioning, Section C408 lays out the processes for commissioning for HVAC and lighting systems. The designer has to document the systems, the control sequences that are going to be used for those systems in plan drawings or the construction manual, so that the code official has reference materials for what control sequences and things are going to be in place. They need to work with a commissioning agent to develop a commissioning plan to test all those different control sequences, make sure they're working correctly. They need to coordinate the timing of the testing, as some of those are seasonally dependent. You can't test an economizer operation in the middle of winter generally because it's too cold, or in the peak of summer when it's going to be operating at minimum condition anyway. So things like that you have to be aware of. So timing of the testing, the test to conduct need to be detailed in that commissioning plan. And that plan also needs to identify the measurable criteria for each test to define what's the pass condition, what's the fail condition, is it working or not. The commissioning agent will then do that testing on the systems and develop an initial report. That initial report will come back to the builder and also get submitted to the code official of any detriments and the plan for fixing them. And then there's a final report completed by the commissioning agent once those have been addressed. That gets submitted to the code official as well, and also to the building owner. Some of this testing can be done by fooling sensors with overrides. So sometimes that timing isn't necessarily a big deal. I know I've seen testing of freeze stats done by turning over a can of compressed air and blowing that on it till it trips the freeze stat. So there's ways to work around some of that timing and stuff. But there are some things that will require specific time of day or time of year testing to be aware of, and that needs to be planned for. So who's doing that commissioning process? The initial plan is going to be a collaborative effort between the designer, the construction manager, and the commissioning agent, again, to work out what are the control sequences? When are we going to test them in the construction process? When are they going to be most accessible? When are they going to be in a state of completion in order to do the testing? The functional testing itself will be completed by the commissioning agent, or they'll coordinate with the HVAC and lighting contractors. So they'll have oversight of the testing and the results of that testing and put that into the report. But usually that commissioning agent's going to be involved in that process. For HVAC and hydronic system balancing, it's an important component of making sure those systems are working properly. That's usually done by the HVAC contractor. The commissioning agent will compile those reports and submit those to the construction manager, the designer. They will then forward those on to the code official, who will verify that that testing is in place, the plan is in place. And usually their involvement is reviewing those plans for the first step, reviewing the initial testing report, and verifying the plan for correcting any failures in the initial commissioning, and then reviewing the final report. Some code officials may want to do spot checks of those tests as they're in progress, but that's not a requirement of the energy code. Per the code, they just need to get those reports, review those, and ensure that that testing plan is in place and is conducted properly. So we have one more poll question here before I hand things over to Todd to dig into actually performing the testing and verifications. We'll launch that poll question. So the first question is, for duct leakage testing, who's the party responsible for that testing? Is it a ResNet BPI certified contractor, the building construction manager, an entity acceptable to the authority having jurisdiction, or the HVAC contractor? And then the biggest issue in conducting commercial commissioning, is it coordinating testing among multiple contractors, coordinating testing with the authority having jurisdiction site visits, or completing that final report? I don't see that any questions have come in yet. So let this poll run for a couple of seconds here. We'll wrap that up. Then I will hand things over to Todd, and Todd will go over the required testing and verification in the field. Okay, we've got a couple more responses coming in here. I'll give this another second. Okay, go ahead and share those results. So the first question, the correct answer is an entity acceptable to the authority having jurisdiction. So it could be really any of these entities listed. It just has to be acceptable to the code official, whoever's doing that testing. And again, we have seen, if it's the construction manager, the builder doing a test on the residential side, that the code official may want to be present for that testing. And then for the biggest issue with commercial commissioning, we touched on initially, was that coordination among multiple contractors. You've got the initial planning that needs to be done, and then setting up the timing of the tests and things. So that's really that most difficult part for that process. The authority having jurisdiction, the code official, usually their site visits aren't tied into the commissioning process. They may spot check a couple of things while they're there for other site visits as they're checking on things, but they're not required by code to actually visually inspect or be on site for any of that commissioning process. And completing that final report may be a subject of opinion there, but usually it's that coordination process that's going to take up most of your time to set up the proper commissioning and making sure that they're done in a timely fashion. All right, so I will turn it over to Todd, and he'll start talking about the actual testing and verification processes.
All right, thanks, Sean, and honored to be here. Happy to be talking to you guys today. First of all, apologize for not having my video. It decided to stop just a few minutes before our presentation started. So both cameras here in the office not working for some reason. But it's what it is. We move on, we adjust and adapt. And just also, I'm from Midwest Building Performance based out of Peoria, Illinois. You may have seen in your email the company Evergreen Home Energy Consultants. That's still me. I'm right in the middle of a name change. And it's a little bit messy to change email, websites, uniform, business cards, all that all at once. So anyways, going forward, Midwest Building Performance is the company name. All right. And Sean, I need to take control of screen. Thank you. And there we go. Okay, so for commercial and controls commissioning, the first step is to develop the commissioning plan. Each system that needs to be tested, the criteria for pass-fail determination, and timelines for the test all need to be spelled out in the plan. There are pre-made checklists available to help ensure items are not missed, and there's a very helpful link here on the slide. It will help with controls commissioning. And as far as HVAC goes, there are basically two components to HVAC commissioning. The first is flow balancing for the air and hydronic systems to ensure the design capacities of the systems are achieved. The second is to make sure the controls do what they're programmed to do. Functional testing is how this is achieved. A couple examples, dampers are commanded to move in the BAS and observe for actual performance and range of motion. Your freeze protection might be triggered by overriding a temperature probe with a command in the computer, or by cooling the sensor to trick the system into triggering protection sequence. Also, you need to verify initial thermostat settings, schedules, and system control set points. As far as lighting goes, for commercial lighting, the key thing here is to pay attention to your room geometries. Rooms with the same setup can be sampled, i.e. not every room needs to be verified. Rooms with different geometries, different orientations of geometry, or different placements of permanent fixtures, they will need to be individually verified for sensor functionality. On top of verifying these sensors work properly for the spaces are controlling, the lighting schedules for timer-based control should be verified, and overrides, both user and occupant over daylight prioritization need to be verified as well. Sean's already talked about duct pressure tests a little bit there. On the left, there's an example of commercial duct testing. On the right, there's residential. Well, here, let's jump into the next slide here. So duct testing procedures, as Sean mentioned earlier, for commercial, reference the SMECNA test manual. Check your appropriate leakage class. Leaks are measured in CFM per 100 square foot of duct surface area, usually at 25 pascals. And you seal a section of ductwork to test on. On the residential side, 2018 IECC defines your test pressure at 25 pascals. And then the passing results are defined by the duct leakage of floor area, not volume of space or system installed. So 4 CFM per 100 square foot, or 300 CFM per square foot if your air handler is not installed. So for example, if you're in a rough-in situation before drywall, and there's no air handler, then you would use the 3 CFM per 100 square foot. But once the air handler is installed, there's essentially allowing a little bit more leakage at 4 CFM per 100 square foot. Let's see. So here's a couple examples for residential testing equipment. On the left is the Retrotech Duct Tester. On the right is the Energy Conservatory's Duct Blaster. Sometimes these tests are called duct pressure tests. Sometimes they're called duct blaster tests. Sometimes they're called duct leakage tests. They go by many different names out in the field, but essentially it's the same equipment. You've got a fan that's going to either pressurize or depressurize the system. You seal off all of these supplies and returns, bring the system up to a specific pressure, and then measure the leakage rate, and hopefully compare it to make sure it passes or fails to your design, your pressures. As far as the basic setup of a duct system, of course, again, sealing off registers and grills. On the right, you're at basically drywall stage, so you've got some duct mask there that's completely covering the registers and grills. On the left, you've got a duct boot coming up through a subfloor that was sealed. Depending on who's doing your testing, they may have other methods of testing these, different colors of tape. They might use foam gaskets. There's different things that people have kind of figured out to make life a little easier on the testing side of things. I will say on the subfloor testing, the trick to one of the hardest obstacles, I guess, is that the tape doesn't always like to adhere to the subfloor, particularly if there's dust on it. It can kind of peel up. So sometimes you can see 2 different types of tape being used to get a little better seal. But I've also seen foam gaskets and whatnot. Anyway, so you get everything sealed off in the system. Obviously, the duct system's installed. Your HVAC system, if it's installed, is turned off. Air filters, if there are any there, are removed during the test. You seal off any combustion air inlets and any ventilation inlets, and then turn on your system, get to the test pressure, and away you go. As far as timing of the duct test, predominantly it takes far longer to set up the test than it does to run it. Usually running it maybe a couple minutes to know what your maybe less than that, know what your leakage rate is. So $1 million question is, what happens if it doesn't pass the test? So as far as the tester's point of view, the first thing they should do is verify their setup. Make sure they didn't miss a supply or a register somewhere. Make sure that the tape is holding on the test. Well, I mentioned earlier, you can pressurize or depressurize the system. You're going to get the same leakage rate. I tend to prefer the depressurization because it sort of pulls the tape up against what it's trying to seal to a little bit. If you're pressurizing it, it tries to kind of push out or balloon out. But I've done it both ways, gotten the same numbers. So it's really a preference. But so assuming your person doing the test has verified everything and they haven't made any mistakes and it's still not passing, and then we're going to take several steps to figure out what's going on. So if possible, if you can isolate your supply from your returns, then you can evaluate both sides of the system, and it will be apparent from the leakage rate if one side is larger than another. Because obviously if it's larger on one side, you're going to spend more time over there. You can also check the pressure at each supply and each return. And I don't have a picture here in the slides, but basically if you take a probe, insert it into the tape right in the middle of the boot and measure the pressure inside that, they should be pretty uniform across the system. But if it's not, then hey, then I know this is kind of where I need to spend some time. So basically, you're checking each one individually, And then the other thing that can be done is the tester can bring in a theatrical fogger or a smoke machine. And in that case, you have to pressurize the system. You blow smoke into it, and you will see smoke coming out everywhere. While that's kind of a fun test, it's also very messy. And it also makes things sticky inside the house. So I don't always recommend it. But sometimes you need that visual to see where the leaks are coming from. So just know that's a possibility as well. Methods and materials for duct sealing. Well, on the lower left, if somebody's failed a test, this is what they're hoping to find. It's some big hole where it takes them just a couple minutes to seal it up. You retest, pass or fail. But in my experience, it's almost never the big hole. It's just a collection of small holes. In the center picture there, you're seeing a picture of duct mastic. This is a paste that comes in a pail and it's applied, hopefully thick, in a very thick coat. Some people call it painting ducts. I wouldn't use that term because paint is a very thin material. You basically want to apply it as thick as a nickel when you're using mastic. So you shouldn't be able to see any gaps or seams in the ductwork when you see the mastic, and I often do. And if we put a smoke machine on it, you'll see smoke coming right out of it. And then on the right, you're seeing an attempt to start sealing some ductwork with some foil tape. You can see one of the seams in that wall stack has been sealed up, but the boot above it has no mastic, no tape or anything. So if we were not passing a test, then I would obviously spend some time sealing those up as well. And then if you haven't heard of AeroSeal, that's a company that can come in and actually seal the ducts from the inside of the ductwork by injecting a bubblegum type of aerosol mixture that can seal gaps, I think up to 5/16 of an inch. That's a pretty small gap, or a pretty large gap that it can seal. But a little bit more expensive to seal ductwork that way, but it does a phenomenal job as well. Okay, so moving on from duct pressure testing to building pressure testing. These are your blower door setups. I pictured there on the left the Retrotex. These are the two major manufacturers of blower door equipment. Retrotex on the left, Energy Conservatory is on the right. Either one is going to be effective at getting you the results you need. So why are we doing blower door testing? Sean mentioned this a little bit earlier, but it's going to determine how tight or how leaky the building is. It's going to give us an overall leakage rate. But beyond that, it's also a diagnostic tool. And whether we're doing new construction or existing buildings, we can use the running of the fan to walk the house and to figure out where points of air leakage are in the house. We can also use the blower door to diagnose building pressure problems, to evaluate moisture problems like condensation and mold. And we do this more in existing buildings, but when we are doing some air sealing projects, we use the blower door to quantify the air leakage reduction. So you do a before test, crew comes in to do the air sealing, and then we do a follow-up test. Maybe it's a 20% reduction, maybe it's a 50% reduction, maybe it's a 70. I'm seeing it kind of across the board, depending on the scope of the work. And then a blower door test can also be used during the air sealing work by the crew that's doing the air sealing. So they can check their work on site. So they can know how close they are to the threshold, or if they've exceeded it or whatnot. All right, so which blower door standard to use? So right now the code says in the 2018, we've got the three ASTM E779, the ResNet ICC 380, and the ASTM E1827. In the BPI world, the BPI 1200 standard references the ASTM E779 and the ResNet standard, although an older version of it. It also references a Canadian standard, but from a code compliance point of view, that standard is not listed in the code. No matter what standard you're using for these are very similar standards. If you dive into the fine details of it, they are very, very close. I'd hesitate to put a percent on it. 95, 98% similarities between them. And I'm sure somebody will argue with me the point. There's probably some big differences somewhere, but I would note that the ICC, the resident ICC 380 actually has a 10% penalty for using a single point blower door test. We're going to talk about the difference between single point and multi-point here in a minute. So preparing the building for the blower door test. Well, the big question for the builder's perspective is everything been sealed? Are the penetrations through the ceilings been sealed? Are the penetrations through the exterior walls been sealed? Penetrations through foundation walls? Sometimes this is simply as just some caulk or some can foam. Sometimes it's a little more complicated. Energy Star has got a very nice reference guide there called the Energy Star Qualified Homes Thermal Bypass Inspection Checklist. If you follow that link or just do a quick Google search for thermal bypass inspection checklist, gives you a very nice checklist of all the things to consider to look for, from chimneys to recessed lights to plumbing stacks to duct penetrations and whatnot. As far as the test goes itself, we're going to close up the windows, of course. That's going to add some air leakage if they're open. Exterior doors are closed, but in contrast, the interior doors should be open. We're going to turn off any exhaust fans that may be present, turn off air handlers for furnaces, air conditioners, and heat pumps. Any gas appliances, make sure they're set to pilot so they don't fire up during a blower door test. We don't want air coming down the chimney. And of course, any chimney dampers are closed. These are just basic steps to the setup that can get a little bit more detailed depending on what standard you're using, but generally speaking, you're going to see these every time. And I mentioned single point versus multi-point blower door test. On a single point test, the person running the test is going to bring the pressure up to, in residential, 50 pascals with respect to the outdoors. They're going to take that reading and they're going to look on the right side of the screen and they're going to get, or depending on what manometer you're using, they're going to get their CFM 50 and that's it. With a multi-point test, the tester is going to spend a little bit more time running the test. Depending on what standard you're using, it may be, you may take the fan to 5 or more test pressures. It may be just throwing numbers out, starting at 60 pascals, bringing it to 45, down to 30, down to 20, whatever the numbers are. And each time the fan goes to that test pressure, the manometer or computer that's being used to run the test will literally take 100 readings at each of those test pressures. And by the end of it, it will give you what this final CFM 50 is. It is not a time-consuming test. If the single point test takes just a minute or two to get to where you need to go, the multi-point test might be 5 minutes. The only downside on the multi-point test that can sometimes happen is if a contractor or a homeowner, who kind of building you're in, opens a door during the test, it might throw off your readings. So you really got to make sure everything stays sealed up during the period of time the test is running. Blower doors can also be used, I think I mentioned, during construction. I have done this with some new construction jobs when I was working with a homeowner in particular, where they wanted to make sure the building was airtight. So we did blower door testing before any insulation was installed. We needed enough of the envelope closed up, so we needed windows installed. But I've had residential homes where we have an attached garage and the wall was completely open to the garage, but we had the overhead door in. So basically, I say that so that we can get enough of a pressure difference in order for us to run the test. But each time we do this test, we evaluate where we're at, and then we do some more air sealing while we're there to bring the house down to a specific leakage rate. And usually what will happen is we'll get it down past the threshold for code before we even install drywall. Just recommend it if you've got the time and the effort for it. When we're looking for, is that me? There we go. Sorry about that. So building tightness using the ACH 50 scale. This is using the volume of the building. So the tester has to know the volume of the building before they run the test. So they're going to know what the threshold is. And the formula for the ACH 50 is basically CFM 50, which is the test result from the blower door, multiplied by 60 divided by the volume of the building. And that will give you your ACH 50 scale. I created a little graphic down there. Roughly speaking, I mean, most houses, whether they're new or old, is going to fall on a scale of 0 to 20. They can come up off this scale and be much higher, but most of them are going to be in the 0 to 20 scale. If you're in the 10 to 20 scale, probably an existing building, probably doesn't have any wall insulation, no effort to air seal in the attic. Once you're getting under the 7 range, you're starting to be tighter. 6 is tighter yet. 4 is where Illinois has been for the blower door threshold. The Energy Code book states a 3. So you get the idea. On the left side of the scale, very tight construction. Right side of the scale, very leaky construction. One of the benefits of using that scale is it lets you compare apples to apples between different houses.
Todd, this might be a good point too to address a question on the 10% penalty for the ICC 380 test. 10% of what? It would be 10% of this ACH value.
I think actually states 10% of the CFM 50. Yeah, so if you get a CFM 50 of 2000, then you might have to add 10% to that to show that's what your CFM 50 is. But in that standard, if you're using multi-point standard, then there's no penalty for using single point. So again, reference, it's important to know what standard you're using and what they state is an appropriate test format. All right. Okay, so like we did with duct pressure testing, what happens if it fails? So kind of 4 steps to this. As far as finding the leaks, first thing is the look, listen, and feel. Then we go into zone pressure diagnostics. Then potentially we do a little pressure pan testing and also use a thermal imaging camera. And I'm going to kind of dive into each of these as we go here. The look, actually I don't have a slide on look, listen, and feel. But basically look, listen, and feel is you're going to walk the house and you're quite literally going to feel the air leakage. The blower door has an effective 20-mile-an-hour wind on all sides of the house. Again, I'm referencing CFM 50. So you can walk up to a window or a light fixture or a penetration, and you can feel the air coming through it. You can also, when you open a door, you'll, like, let's say you walk up to an interior door and close it to just about, let's say, a 1/4 inch or 1/2 inch open, you're going to feel the air rushing from that room towards you that's going to the blower door. The more air you feel coming through, the more leakage is in that particular room. And then you can also look for building materials or curtains or different things that might be quite literally blowing in the wind because of so much air leakage. So that's kind of the look, listen, and feel, but you can also do a little bit of diagnostics to basically quantify this a little bit. And that's where the zone pressure diagnostics comes through. So your blower door's running, you basically put a hose under the door, shut the door, look at the manometer and read the pascals of pressure difference between the room and the rest of the house. And you can use that to quantify where you're at. So on this particular scale, if you're doing a CFM50 test, your scale of good to bad is 0 to 50. Well, I didn't say good to bad. If it's an interior room, you hope to be, 0 pascals, 1, 2 pascals, something close to 0. Let's just call it less than 2. But if it's an interior room and it's 25, 30, 40, 50, you've got a major problem. And it may simply just be, hey, a window was left open. Close the window, retest, you're going to see the number drop immediately. If you're testing an area that's not part of the thermal envelope, like it's not a dining room or a break room or whatever you're testing, let's say an attached garage, that number should be on the opposite side of the scale. So the garage should be closer to that 50, or an attic space or some other unconditioned area. So the zone pressure diagnostics is a nice little tool that can very quickly help diagnose, where the biggest bang for your buck is. Here's the garage example. So we've got a manometer in the house. There's an attached garage here. The connection of the garage is 48 pascals with respect to the house. So because the garage is outside of our envelope, we like that number. That's where that thumbs up comes from. In a different scenario, you test that garage and you get 5 pascals. That's basically like a bedroom in the house. That's very well connected. We want to make sure that garage is isolated from the rest of the house. So that's just another example to look at it. You can also test unconditioned attics with a very similar test. Again, the attic should, assuming it's an unconditioned attic, it should be as close as 50 as possible with respect to the house. We can also use zone pressure diagnostics to help diagnose problems after the building is completed. We use that to diagnose attic moisture problems, ice damming problems, indoor air quality problems. In particular, if the attic, the attic floor is very leaky, a lot of conditioned air is getting into the attic, there's a big danger of moisture problems in the attic. Like today, it's 10 degrees outside. That attic roof deck, if you have a very well insulated attic, should be very cold. But if air from the house is getting into the attic, it's going to hit that cold roof deck and condense. And in the picture, you're seeing moisture damage and some white and black and some wet and dry. We don't want that to happen. Now, there's a lot that can go into solving that problem, but a lot of it is air leakage from the house into the attic. So we can use zone pressure diagnostics to figure that out. And the pressure pan testing, generally, you're going to be using this test primarily for testing how a duct is leaky that's in an unconditioned space. So the pressure pan there is in the picture, and then there's a supply register in the ceiling. That supply duct is in the attic. So let's say we have 4 or 5 different supplies in the ceiling. We test each one of these with our pressure pan, and kind of like the zone pressure test, we expect a low number. If it's a high number, then we know we have an issue. And we can do a little bit of duct sealing to actually seal up the building. And then the other thing that's not too difficult to use, as long as you are skilled at looking at images and knowing what you're looking at, I know what's good and bad, is using the thermal imaging camera or the infrared camera. These are used to troubleshoot building envelopes. They're used to look for insulation and air sealing issues, and can even detect some moisture issues as well. The person using that camera must know their temperatures between the indoors and outdoors. I can't take my camera every day of the year into a house and expect to use it. When it is 70 degrees outside and it's 70 degrees inside, I can't use it on the walls. There's not enough temperature difference the camera's not going to pick it up. If it's 70 degrees outside and the sun is out and it's the afternoon and the attic temperature might be 120, 130, I can use the camera on the ceiling and probably see some problems. But on the same day, I wouldn't be able to use it for the walls. So knowing that temperature is massively, massively important. And in certain jobs where that infrared inspection was so important, we've actually scheduled around weather or rescheduled around weather if, it turns out it was going to be too temperate that day. So from an infrared point of view, I like hot and cold weather, not nice 70-degree weather. If I'm off for the day, I'd rather have a nice day. But if I'm working, I actually want those extreme temperatures. Most cameras need 18 degrees delta T difference of temperature between indoors and outdoors. Some of the better cameras can get good images with about a 10-degree delta T. But roughly speaking, 18 degrees is generally what's accepted as the temperature difference. So if you have that temperature difference, they're fantastic tools. Okay. Here's an example of using an infrared camera. This actually was a house that I was in to solve a moisture problem. It was constructed in 2015. And I used my camera walking around the house looking for different things. And I didn't have a moisture problem in this room. And I looked at the ceiling and it was 30 degrees outside. And basically I found a ceiling completely uninsulated. This is another view of the same room. And I asked the homeowner, I said, and I wasn't there for comfort issues, but I'm like, hey, is this room kind of cold in the winter and hot in the summer? And they're like, yeah, it's terrible. I'm like, well, they missed an attic. And this is the same house. And I can kind of see why they missed the attic, because if you come across here is the ceiling of that room we were just looking at. This is a vertical wall between a second floor bedroom and that attic space. And there was no attic access left to get into the space. The other clue I had that there was a problem is when I was walking around outside, taking a look at the building, there was frost in the roof deck, but this section had almost no frost whatsoever. And so I knew this was something that was going to be entertaining to see. Entertaining from a building science point of view, not so much for the homeowner that's got to pay money and have it fixed. So yeah, the infrared camera can find some big stuff, but it's not always about the big stuff. When you are running the infrared camera, this image was taken in the summer when it's very hot outside or hot in the attic, and the blower door is running at the same time the camera is being used. That's the best time to take a picture. If you want to see air leakage with a camera, this is what you do. So we can see wire penetrations. These are holes through ceilings and through top plates from ceiling fans, ceiling lights, smoke detectors. So if we haven't passed a blower door test in new construction, or we're in existing trying to solve problems, basically the same thing. Here's an area we can address. Here's an example of top plate leakage with the thermal imaging camera. The view is in a hallway, looking at top plates on both sides. It was a summer picture, so all that hot air is just coming right through the top plates, down into the walls and into the house. This is a cold weather shot. So again, the darker colors are bad colors. Again, notice the streakiness here. That's, again, the blower doors running, giving me that 20-mile-an-hour wind. The camera's on at the same time. So you can actually see it. So we're missing some weather stripping under this attic hatch, and even some caulking and possibly some missing insulation here on the side. The picture on the right is not very good, but the picture on the left, infrared, is great. This is an attic access panel that actually was not drywall. It was just basically plank boards run together, and you can see the gaps between them around it that need fixed. This is a view, again, blower doors running. It's cold outside. We got cold air coming through a top plate. It's also coming through a return at the same time. Now our codes today require our returns to be fully ducted. This image was taken before those were fully ducted. So you're an existing house, you've got just wall cavities for returns. Understand that when you turn on a furnace, air conditioner, or heat pump, and it's pulling air into this return down into the system, it's also pulling air from the top plate down into that wall cavity as well, if the top plate's not been sealed yet. So you get a little bit of a double whammy. Anytime you turn the HVAC system on, it's going to cause building leakage at the same time. And then we've got to deal with those BTUs of heat and particulates that may come out of the attic. Drop soffits, residential commercial buildings often are open to their attic above it or the floor system above it. And this is a winter shot, a cold shot, where you can see that soffit is very cold. You can see the air leakage to the recessed light. So we know that's where we can find an issue. Recessed lights, can lights, pot lights, eyeballs, a lot of different names for them. They're all notorious for leaking air. Again, the blower doors running, showing all that air coming through the recessed light. You don't have to have the blower door or camera. You can just put a hand up there and you can feel that air coming through it. So we'd like to see those sealed up. For example, this is recessed lights in an attic that have been sealed with boxes made for recessed light can covers. Basically a cardboard box with a coating on the inside to slow the ignition to fire. And the infrared camera can also show how some ceilings aren't proper air barriers. So we've got some tongue and groove wood paneling, looks nice on the right hand side, but on the left it's not so good from a performance point of view. And that, fortunately for her, this was just a closet. Almost hate to say it, but the tongue and groove paneling needs taken down. We need drywall first, taped and mudded, then put the paneling back up to give that nice wood look. But don't rely on the tongue and groove paneling to be an air barrier. It may not work. Same thing here. These are tongue and groove. This is beautiful A-frame living room, but he was getting moisture problems coming out of these seams, particularly at the lower wall. Air from the house was getting in between these panels, hitting the roof deck, frosting up and melting and dripping down to the exterior wall and getting water on the exterior wall because we don't have a proper air barrier here. Ah, there we go. Sean? Sean, I lost your audio.
I sat on my mute button.
Yeah.
So just kind of an overview there. Most of what Todd covered is existing building diagnostics, or if you're working in new construction home and it doesn't pass, then you can use those diagnostics to figure out where the issue is and fix it. As far as code compliance, the required testing was listed at the start there, the blower door testing and the duct blaster testing. And Todd, we did have a question come in for that. Is it wise to test both pressurization and depressurization and compare the two results, and both for blower door and duct blaster testing? Or should you get the same result from both?
You should be getting the same result from both. I will note that some of the blower door standards, some of the procedures actually ask you to do both during the same setup, where you'll take a number of readings in depressurization, flip the fan around and take a number of readings in pressurization. In my anecdotal, I guess, experience, I really didn't see any significant difference between doing either. From a functional, practical point of view, on a blower door, much easier just to do a depressurization test because everything you need on the fan is in front of you. With the duct blaster test, my preference is depressurization, but again, you can turn the fan around and do pressurization. If you're going to do the fogging of the duct system, you definitely have to pressurize the duct system to do that test properly.
Okay. We do have a couple more poll questions to launch here before we get into a couple more of the Q&A that have come in. But for the multi-point test, why is that preferable to the single point blower door test? Is it because that regression of multiple points yields a more accurate result? Better adjust for pressure swings due to wind during the testing? The single point test requires a 10% penalty if you use that, or all of those. And then the second question, what is the main difference between new construction and existing home air leakage testing? New construction testing is easier to complete than existing. Existing home testing is paired with other diagnostic tools, or there's no significant difference between them. We did have a question come in. What are some of the most common leakage points and what would the repairs be?
Some of the common leakage points, I mean, there's numerous leakage points. If you're trying to pass for a code, you're kind of look for some of the big ones. I would be, one of the big things I would look for that might get you a big jump would be if you've got any knee walls that don't have any blocking at the bottom, where air from that attic can get into the floor system. But other than that, you know, any penetration through the ceiling, any penetration through the wall. I didn't really talk about windows, but we want to make sure that rough opening has been sealed before we trim it out. But if you're after trim, you know, you can caulk that trim to the drywall connection. I will note that what I find in the field on windows is kind of interesting. I will see if they're going to caulk around the trim, they caulk the left and the right side, but they don't caulk the top and the bottom. Why? I'll let other people conjecture on why the top and the bottom aren't sealed when the left and right are. But yeah, obviously caulk around your windows, your rim joist down in the basement can be a big one for air leakage as well. But it really kind of depends on the house. It's kind of where using the look, listen, to feel and your zone pressure diagnostics can quickly kind of determine, okay, here's where the big stuff is.
Okay, looks like we've got most of our poll results in. We'll go ahead and share those as we answer some of the questions. Looks like everyone got the first one right. All of those are true. Doing the multi-point test does help compensate for any wind that might be blowing outside. Having that regression from multiple points of pressure test and multiple tests at each pressure level does remove some of the inaccuracy of doing a single point test where you've got wind pressure, temperature differences, all of those can affect that test. And then also there is that 10% penalty for a single point test to that CFM50 number. The main difference between new construction and existing home air leakage testing is primarily for existing homes, you're going to be pairing that testing with other diagnostic tools in order to figure out where your issues are at. So if you do a pressure test in a home and you got a really high leakage number, now you're going to need to figure out where that leakage is coming from. So outside of that, the actual testing requirements for existing and new construction are similar as far as performing the tests. Okay. Let's see here. For can lights that have a so-called airtight rating, how do they fare in the real world? I think Todd can attest to this, but usually if they're installed and gasketed properly, you're not going to have much issue as far as air leakage through those contributing to your overall air leakage number. They do leak a little bit. Any light fixture will, just because you have to have connections through it. But as long as they're properly installed and gasketed, they fare pretty well. Todd, have you had any experience with the airtight rated can light fixtures?
I basically concur. I mean, they're not perfect. They're still going to leak some air. I would almost care less about the rating as if it was just boxed up and sealed in the attic. Or better yet, don't use the recessed light in the ceiling to the attic and just put some track lighting or some different style of lighting that doesn't create a large penetration like the recessed light does.
Question here, how much might one anticipate paying for a blower door test? Do you have any sense as to how commercial building testing might be charged? Is it per square foot basis of floor area or of envelope area? Is it a tiered rate? I know when I was doing residential testing, we had a flat rate for new construction testing. And then for existing homes, it depended what we were doing as far as the performance report for the client. But we had a flat rate for just a blower door test. I'm not sure how Todd does that for his business.
Yeah, on the residential side is a little more straightforward. I have seen in practice the installation contractors doing the test, and they just basically do it free as a part of their job. I've seen third-party testers charge anywhere from $150 to $300 or $400. Kind of depends on how far they have to travel for a job. And in most cases, the building is small enough that one blower door is going to do it. But if you're doing a very large building and you're going to get multiple blower doors and travel and all that, that's going to drive up the cost. So it's hard to give that a range on the commercial side at this point. I mean, it's going to be quite a bit.
Yeah, I would expect with the difficulty with commercial buildings, with the larger square footage, generally going to have more systems as far as HVAC systems in the building, which is also going to increase the number of penetrations you got through the envelope. So I would expect as commercial testing gets ramped up, that those are probably either going to be a tiered rate based on square footage or a tiered rate based on something like number of HVAC systems, something along those lines. But yeah, I'm not sure on the commercial side how they're pricing those out yet. We'll have to see how that evolves. For multi, go ahead.
So I'm just saying it's early days on that. So
for multifamily, is there emphasis in the energy code for sealing common walls to reduce leakage from adjacent units or corridors? What are some strategies to ensure common walls between dwelling units are well sealed? So as far as the energy code is concerned, they don't specifically call out common walls, but the reference materials for how to do the leakage testing for individual units, there's two different ways that you can do the test. You can do a compartmentalized test where you're testing that individual unit, in which case you need to be concerned about air transmission between it and neighboring units and corridors. Or you can do kind of a whole building test. I believe the testing requirement for multifamily homes that's currently in the Illinois amendments is a compartmentalized test. So that individual unit gets tested and the air leakage for its exposed envelope area is the that required 25 CFM per square foot leakage value. So you do have to be sure to touch up the common walls and make sure that they are sealed properly. As far as strategies, the main thing is proper drywall taping on the unit sides, and then between that party wall, making sure it's sealed off at the top plates from the attic, and at the exterior wall, making sure that your air barrier is continuous across that that interface between the two units at that party wall. For the interior side at corridors, it's very similar. You want to make sure that the top plate is sealed, the drywall is properly taped and mudded, just to limit that transfer. The primary air barrier is going to be that drywall for the interior party walls. Todd, you have any more comments on those?
Yeah, a couple of them. The motivations in multifamily, I mean, to me, go beyond energy efficiency. If I was a maintenance manager or multifamily, I really want each apartment sealed from each other apartment because you don't want the noise and the smell transfers, from cigarette smoke or weed or what or curry or whatever's going on in the next apartment that somebody else doesn't want to smell. So sometimes your motivations for doing something, yes, it's great for energy efficiency, but has these other side benefits that can be very impactful to the occupant. And then the second thing I was going to actually ask you, Sean, can you talk in your experience is because we talked about multifamily, you either measure each unit, do a whole building. What about doing a sampling of units? I've seen some code officials saying, okay, 100-unit building, if you do certain percent of units with each floor plan represented, as long as those pass, they were okay with that.
Yes, that is allowed in the energy code. So units with different configurations, like a corner unit would have to be tested, and then a core unit, and then a unit directly under the attic space, and a unit directly above the slab floor. And the same thing for corner units at each of those. In each orientation would need to be tested. But the core units are where you really kind of benefit from the sampling. So you would test every few units in that case. Jerry had a question about the 2021 blower door testing requirements for smaller homes. I'll have to dig into that for you. I don't have an answer currently for you. Again, we're still focused on the 2018 IECC for this presentation, but we will be touching on those as the 2021 gets released. We get closer to that release line. We'll start focusing our materials on those impending changes. So we'll work on an answer for you and get that to you soon. We had a question, what are the benefits from tighter envelope beyond just utility savings? So Todd, I know, yeah, go ahead.
I mean, sound control, moisture control. I mean, comfort is probably one of the biggest ones. The more you can keep that conditioned air within the house, the better. The tighter the envelope, the more likely you can get smaller and more appropriate sized heating and cooling systems. And then I will also, because I do a lot of calls solving moisture problems in buildings, of preventing moisture problems within framing cavities, such as wall cavities, and of course up into the attic as well. So almost from a liability point of view, you want that tight envelope to stop that conditioned air from getting into the wall cavity or getting into the unconditioned attic, where it can condense and start to grow funny stuff.
Pest control is another one that
right
in the chat too. If you're sealing up those holes, there's less opportunities for insects and things to enter into the building.
And I think it's easier to provide a better indoor air quality when you have a tight envelope, because in your ventilation system, and there's many types out there, you can take better control of it, because the mantra is build tight but ventilate right.
And we do have a final question here for, I believe, multifamily buildings. Will testing be mandatory for individual units in the 2021? I know currently the Illinois amendment, it's a sampling of 1 of every 7 units with a minimum of 7. I will have to look into the 2021 to see what the updates are for that particular requirement, but we will get back with you and answer that question.
Did we mention the expected live date of the 2021?
I believe it's June or July of 2022 is the prescribed date for that to be coming out.
And do we expect any potential amendments to be determined here in the next few weeks or months? Or
we've had a review of a few of them. I'm hoping that we'll either come out with a Hvac or a newsletter article addressing some of those proposed amendments. I am not currently aware of them. I know one of the members of our office has been involved with that more than I have. We do have another question here. I hear a statement a lot when dealing with air tightness of the house that the tighter the house, the more chance of sickness in light of COVID. Do you find this to be true? That goes back towards the build tight, ventilate right. If you're doing proper ventilation of the building, bringing in filtered, conditioned outside air, then the risk of sick building syndrome, where the building's so tight that you don't get fresh air into it, contaminants build up, should be mitigated. And we tend to find that with leakier buildings where that's uncontrolled, you have more health issues with mold and moisture damage and things. Todd, do you have any further comments?
Yeah, I think it, I mean, the thing I worry is if we have a lot of tight buildings that don't have any kind of ventilation system in them at all, but it is written into the residential code. So from a code perspective, having some kind of ventilation system, whether it's exhaust only, supply only, or balanced, and I could go on and on about the types of systems, but some kind of system to provide that air exchange to keep that carbon dioxide down to an acceptable level so that we don't have a buildup of contaminants such as viruses.
I do think we'll see. Go ahead.
Sorry, go ahead. No, go ahead.
I was just thinking, in light of COVID, I think what we will see is an increase in filtration on HVAC systems to try to better filter the air instead of having the minimum filtration to protect the equipment. But as far as the ventilation, as long as we're meeting the code ventilation requirements, I don't believe that the tighter houses will have a detrimental impact because we're still bringing in that fresh air. It's just at a controlled rate.
I saw a comment from Ryan in the chat that the Illinois amendments were approved yesterday and were forwarded to the CBD and the governor's office.
Yep. Okay. I think that's all the questions that have come into the Q&A. I didn't see any pop up into the chat. So, Todd, thank you for joining us today and your insights into the actual performance testing. Everyone else, thank you for joining us today. We hope you found the webinar useful and insightful. If you have any further questions, please reach out to us at energycode@illinois.edu. We'll be happy to connect with you and answer your questions.